This nugget will examine the question, how has the structure of the Earth changed? Our Earth has an internal structure with several layers. Around the outside, there is the atmosphere. Our land masses and oceans are on a layer called the crust. At the centre of the Earth, there's the inner core. Surrounding this, the outer core. And below the crust there is the mantle. But has the Earth always been this way, with its crust and atmosphere as they are today? Let's take a look. Today our world looks like this. The land masses of the Earth's crust are arranged into the continents. But has it always been this way? Could they have been different in the past? The scientist, Alfred Wegener, suggested that the continents had been in different positions in the past, that they were once connected. He described them as being like puzzle pieces that were once attached. If you look to the structures of South America and Africa, you can see there is a pattern, that it makes sense that they could have been connected in the past. Wegener used evidence to back up his theory. He identified that similar fossils appeared in both South America and in Africa. Fossils are the remnants of ancient organisms in rock. There are different animals around the world, so the same fossils in South America and Africa didn't make sense, as the areas are not connected. Other scientists need to agree with your point of view for it to become accepted. Wegener's observations were dismissed by the scientific community, as there was no understanding of how continents could move. They suggested that bridges of land must have previously existed. This would explain how there were the same ancient creatures in both South America and Africa. These land bridges are not correct and have now been disproved. Wegener's work was accepted when it was discovered that plates of the crust could move. The continents of Earth sit on the plates. It was discovered that the plates of the mid-Atlantic are separating. This discovery meant Wegener's work was accepted, and the movement of the Earth's continents is explained with the theory of plate tectonics. Plates move because of convection currents. Liquid rock in the mantle of the Earth moves. Warmer rock rises, and cooler rock sinks. This is due to convection. The convection currents push the plates above and cause them to move. So how did the continents used to appear? The land masses all used to be joined together. This supercontinent is called Pangaea. This is what our Earth's crust used to be like, with all of the land masses combined. Over time, the land masses separated due to plate tectonics, giving us the continents we have today. So how has the structure of the Earth's atmosphere changed? The early atmosphere of the Earth is believed to have been caused by volcanoes. Volcanoes release gases. They released carbon dioxide and water vapour. This made up almost all of the Earth's early atmosphere. There was very little oxygen in the early atmosphere of Earth. Over time, the atmosphere of the Earth changed. Water vapour condensed from gas to liquid and formed the oceans. Carbon dioxide dissolved into the oceans. This reduced the amount of carbon dioxide in the atmosphere. Algae are a simple type of plant. Plants complete the process called photosynthesis. Photosynthesis releases oxygen as a waste product. Over time, this increased the amount of oxygen in the atmosphere. Today, the Earth's atmosphere includes the air that we breathe. 21% of the air is oxygen. Other gases make up 1% of the air, including carbon dioxide, now down at 0.04%. Nitrogen makes up 78% of the air. So in summary, plate tectonics explain the movement of the plates in the Earth's crust over time. The continents used to be joined, but separated through history. The early Earth atmosphere is believed to have been formed of gases released from volcanoes, mainly carbon dioxide and water vapour. Over time, water vapour condensed to form oceans, carbon dioxide dissolved into the oceans, and oxygen was produced by plant life photosynthesizing. And our keywords. Tectonic plate, large structures that make up the Earth's crust. Crust, the layer of the Earth's structure with land masses and oceans. Mantle, a layer of mainly solid rock. Convection current, the movement of warm fluids upwards and colder fluids downwards. Plate tectonics, the movement of tectonic plates. Pangaea, the name of the land structure when the continents were joined together. Fossil, remnant of historical life forms left in rock. Atmosphere, a layer of gases surrounding the Earth. Air, a mixture of gases found in the atmosphere today. Volcanoes, geological formations where liquid rock reaches the surface. They release hot gases.